Finland 2012, and during 2013 to 14, he was postdoctoral researcher at Aalto University. In December 2014, he joined as an assistant professor at the International Institute of Information Technology, Hyderabad, where since July 2021 he is working as associate professor. Sachin's research interests are in the field of signal processing and machine learning for wireless communication, and particularly in the physical layer aspects of the Internet of Things, 5G, and cognitive radio. He is the coordinator of the Center of Excellence on IoT for Smart Cities at IITH. He is a senior IEE member and the representative of IIITH to the Telecommunication Standards Development Society of India. He is also actively involved in India's first living lab for smart city research at IITH. These are all the Sachins. Sachin, you can start.
Thank you. I hope that all of you are able to hear me loud and clear.
Yeah,
thank you for the confirmation, and thank you very much, Dr. Loknath Reddy, for the nice introduction. And also thank you, ICAR, as well as you for inviting me for this talk. So good morning to all of you. And so today I will be talking about Internet of Things and in general, its introduction, what kind of applications are there, and what kind of research we are doing at IIIT, especially my group on IoT. So already so talked about my research part. So here is the outline of the presentation. I will start with the introduction. I will try to motivate the importance of IoT with some applications, and then I talk about the few of the IoT activities at IIIT. So if you look at the let's say if you try to understand what is IoT, right? So you will, if you try to search this online, then what will happen is that you will get hundreds of results. So you will get hundreds of definitions which will contain a lot of jargons and mumbo jumbo. So to understand what is IoT, we need to understand what is Internet, which we are using day in, day out, right? And especially in the age of social media, as well as even more during the COVID-19, right? So if you try to answer that, so basically what is Internet, right? So Internet is nothing but it's a network of computing devices. It is basically a network of computing devices such as laptop, your computer, server, tablets, your smartphones, right? So now if you extend this definition of Internet to things of everyday use, you get your definition of Internet of Things, okay? So in this particular case example, you can see in this figure, you can see that I can attach a bulb. Nowadays, there are so many smart bulbs, even fans. You can also attach Internet to the, let's say, to the plants. We can attach it to cycles, anything. So that's the basic idea, that you are extending the definition of our Internet to things of everyday use. So you will say, what's the difference between connecting a computer and any other device to the Internet? So there's a big difference. The traditional Internet, it talks about Internet of computers, okay, or computing devices such as phones or tablets, where the main task of the device is computing, okay, and running programs, and its general purpose. I can play video games on my laptop. I can do coding on that. I can run MATLAB. I can run different applications on this. I can write basically documents. I can watch movies. So there's so many things I can do. So it's a more general purpose. On the other hand, if you see the IoT device, the main task is not computing here, right? It's if you take an example of washing machine, the main task is not doing watching movies and everything, but it's the main task of washing machine is washing clothes, right? So I'm saying here, so the IoT devices here will be for very specific application, and one of the main thing here is that it has to be very cheap. Otherwise, it should be a fraction of cost of the actual hardware you're connecting the Internet to, right? So if washing machine is costing 16,000, so it should not be, the IoT component should not cost more than 1,000 or not more, not too much. Then if you see, on the other hand, computers are very expensive, right? I can't actually connect your iPhones or your smartphones to things of everyday use, that will become very prohibitive. You can't scale, you can't connect basically your phones to everything, because the first thing is that they're very expensive, then they consume a lot of power, and the things don't need that much of basically computing, right? So we'll talk about it. One example is that temperature monitoring, right? So I don't need a smartphone to monitor temperature. I'm saying I don't need to connect a smartphone to a temperature sensor physically to connect it to the internet. Right. So then you will ask me, how do you connect to internet, right? So for that, we need to embed a electronic chip, something like this, which will contain at least sensor or actuator, a microcontroller, a communication module, and a battery, right? So sensor actuator, basically sensor, let's say, will kind of monitor some physical phenomenon here, and microcontroller will do all the computing. It will interface sensor, and it will also make sure that the data can be sent to internet through the communication module. And battery is needed for powering the device. Keep in mind that we want to connect several things, right? I showed you that picture where several things are there, and then there are so many, like many thousands of things which we can connect to internet. So as I mentioned, and it is very important that they are low cost and low power. You don't need to keep changing battery for every other thing, right? Let's say my room, I put everything connected to internet. I will keep changing battery every other day, right? I don't want to do that. So we need to make sure that it's low power and low cost, which will mean that the device itself will have very low computational power and low storage, right? Then this is how the Internet IoT works. So you have sensors here which are monitoring some physical phenomenon, and basically the sensor devices, they will send data to the gateway which is connected to the internet. On the internet, data is sent stored somewhere, and it can be analyzed somewhere. And based on analysis, I can actually send a command to the actuation signal to some kind of actuator. So one example can be that we have a network of, let's say, pipes, distribution pipes for water distribution in the campus. So if I sense a leakage in one of the pipes, right, then I can basically control the valve which will stop flow in that particular section of the, let's say, distribution network. So this way I can actuate, I can sense, and then based on the requirement, I can actuate something else for efficient management of water. So you will then ask, why do you even need to connect the thing to the internet, right? So if you now take an example to answer this question, if you take an example here where you can see a simple speaker and mic, right? Now, if you connect this simple speaker and mic to, let's say, internet, what happens? Suddenly you have smart speakers like Amazon Echo and Google Home who have knowledge of the complete world. I'm saying internet has all the knowledge, right? The world has. So suddenly they are connected to the whole knowledge ecosystem, and they can answer anything to you, right? You ask any question, then they can answer anything, and they can have very interesting applications with this Alexa and let's say Google Assistant. Another interesting application is shoes. So we will say that, why do you want to connect shoes to the internet, right? I'm like, that doesn't make sense. So if you think, so all our applications, all the IoT applications are, or the applications of IoT can be really amazing, and they are limited by our imagination, right? So if you take this example of the smart shoes here, the idea is that if I embed different sensors, like let's say GPS, Bluetooth, camera, then suddenly this shoes become smart shoes, and they can help a blind person navigate streets in the city, right? Even if I, let's say, put a pressure sensors in the shoes, that they can help us basically monitor our gait, monitor our gait or the way we walk, right? So over the time, if the pattern changes from your normal walking behavior, it will start indicating about some issues with the leg, and this can be detected much earlier as compared to, let's say, when the injury actually happens, like something really goes bad. So we can take some preventive action in that sense. So I already mentioned about why do we want to basically add internet to the things, right? So the idea is that we want to make things smart. And here the idea is that to be smart, a thing doesn't need to have a super storage or supercomputer inside of it. All a thing has to do is connect to super storage supercomputer. This is a powerful definition or powerful concept that I just need to have all the time connection. If I have connection, basically my device is super device. It's a smart device. And what this IoT can do, right? So for consumers, it can basically bring ease of access. I can control any device from anywhere. I can control my AC from house. I can control my gas meters from house. I can monitor them let's say I can monitor my house from my office. So I can do so many things. Not only this, it can also give you insights on what's happening and automatically do things for efficient system management and reducing of bills, right? So let's assume I will talk about one example soon on this. Then for companies, it can again give so much very interesting applications can be there. One example is real-time monitoring and response. It also reduces the human errors, which will help in increasing productivity, and it also does predictive analysis. So what do you mean by predictive analysis? That if it can tell if something is going to fail in next few days or next few days, and if you already know that something is going to fail, we can actually order those, let's say, components or spare parts for them much in advance, so that the downtime to replace those can be reduced to minimum, right? So any time shutdown happens in a company, that's a huge loss, right? So to keep that shutdown to the minimum, IoT can be of real use. So are there any questions till now? Okay, so fine. So these are the top 10 applications of IoT, and you can start with smart city, which is very, very broad term. It can include waste management, traffic management, water management, environmental monitoring, so many other things. So smart city, pretty broad topic, and also very important given the smart city mission has declared 100 smart cities in India since 2015. So this is a pretty important topic from Indian perspective. Then we have smart industries or industry 4.0. Then you have smart buildings, autonomous cars, smart grid, and we also have a smart agriculture in the top 10. And as I mentioned, the number of devices, the IoT devices, are going to be in billions. It's going to be 10 times, 20 times, 100 times the number of mobiles. Okay, so each person right now might have 1 or 2 mobiles, I'm saying, and maybe more than 4 to 5 devices at least in house connected now. Soon this will become 20 to 30. So we will have 20 to 30 things connected to per person. So suddenly you will say that the number of connected devices will explode. And that is the reason why all the companies, big and small, are interested. See, it's very natural that big companies would be involved since the market is pretty big. But what is very interesting here is that even the startups have a chance. Like the amount of time and effort to come up with a solution, a particular solution for a particular problem is, let's say, very minimal. 6 months, a team of 4 to 10 people can come up with a very good solution, which is not generally possible for a sector like wireless communication, cellular communication, if you see. Okay, there you need a lot of things. So that is the reason there are many companies in IoT, and everybody wants a pie of IoT. So let me take some use cases here. So let me start with, these are my favorite use cases. I really like them. And like, they might be slightly old, but the idea here is to tell the use cases which are kind of a path breaking. Okay, so the whole idea is that So what is, before we go to the thermostat, let's first talk about what is thermostat, right? So basically the thermostat is this kind of a device where you set the temperatures, right? Just like you must have this in AC. For India, we generally have it for cooling the house, but abroad, it generally in winters, people want to heat their houses. So people have this centralized boiler where water is getting, basically hot water, people will boil the water, and then this hot water will go through the different rooms in the house, and through radiator, it will emit the heat and keep the place warm. So thermostat basically decides, controls the amount of water which is flowing inside these pipes, so that we can then control amount of the kind of temperature we want to set in the house. So you can see that, first of all, this is designed by Apple engineers. So you can see that the difference between this and this, it's amazing. The kind of design you can see is amazing. Then very interesting is that this is a AI/ML based kind of a learning thermostat. So what it does is that whenever you change the schedule, so you touch the knob or changing settings, it keeps in mind what time of the day, what time of the year it is, and that you're changing the setting. And based on that, it learns your patterns, that what time of the year, what time of the day you like, what setting, what temperature you like. Okay. And then when you're home, when you're not home, everything it learns, because suddenly simple, one device with few parameters is suddenly able to predict everything. Okay? So let me quickly run a video here. I hope that you are able to see the screen.
Yeah.
And yeah. So very interesting thing, right? That it can understand which room you will be using and which during what time of the day and everything, right? So I'm saying then it can switch off that part, the heating in that part, and then it can basically cool only or heat only the part where you are going to be there. It can also, let's say, heat up the house or cool the house depending on the outside temperature before you reach the house, right? So a lot of interesting thing can be done here, and based on this simple device, basically Google acquired the Nest Lab, which made this for 3.2 billion, something which is a pretty big amount. Even when Nokia was sold, Nokia phone, let's say the handset unit was sold, it was sold only for a few $1 billion after like running for many, at least 2 decades, after running 2 decades, and still it was sold for a few billion. And here in 4 years, they were able to convert a $1 billion company on a very interesting, small but very interesting idea. So that is the power of IoT. That's what I want to emphasize here. Then another video I have here is of this replenish Amazon Dash. Let me again.
Don't let running out ruin your rhythm. Introducing the Amazon Dash button for Prime members, a simple way to reorder the important things you always run low on so you'll never run out. Set it up to order what you want, then press it when you're running low. Get an order alert on your phone so it's easy to cancel if you change your mind. And with Prime shipping, you'll get new products delivered to your door before you run out and never miss a beat. Prime members, request your Amazon Dash button today.
Okay, so pretty like simple. So the job of this device, IoT device, it's configurable. Basically, the only job of this device is if you press that button, it will order whatever it is attached to. Just like in this particular case, it will order this Tide washing powder for preset amount, which is basically you can set it in your phone, right? So very simple, but the point is that we can come up with some very interesting applications. So what this application was, the whole application is, it's a replenishment services. Basically, if it is getting over, you press this button and automatically it will order for the same thing for you. That's the basic idea behind this product. But the the point I'm trying to make here is that such a simple thing, I'm saying again, a very simple application which can be made and which can have huge impact. By the way, this has been discontinued after Alexa came and subscriptions came. Like you can now just say, Alexa, order me this, right? But again, I'm just trying to tell you that how simple it might be. It totally depends on our imagination, what applications you want and how to make them. So coming to the agriculture, again, so here we can monitor several parameters of soil as well as the environment. And I have mentioned here several things: pH level, temperature, airflow, water, manure, fertilizers, nutrients, and light. And based on this, we can then decide what plants might be better, or we can actually optimize inputs, how much water to give. Let's say, otherwise, what is generally happening in the irrigation part is that sometimes we give more water or sometimes we give very less water. So those kind of, and even the other things like fertilizers and pest control and all, right? So all these things, sometimes you give more, sometimes you give less. So it's very, very important to let's say have all these inputs optimized. So IoT can help here in the sense based on different parameters, which I mentioned already in the list, and there can be many more. You guys are expert on this. We might be able to tell much more, but I'm saying it can take into account several parameters, very complicated, complex relation between them, and still it will be able to tell you based on some AI/ML algorithms that what might be a good, let's say, crop selection planning, or what should be a schedule for the let's say irrigation, fertigation. It can also help in detecting diseases, right? If you put a camera and it takes pictures of the, let's say, plants once in a while, and then sends it, and online or on the edge itself, we can detect what kind of diseases are there. Also, we can, based on the kind of the volatile organic compound, the VOC gases which are released, if there's a pest attack or something, we can actually detect if the plants are under attack. Or this is much before even they will show any symptoms on the leaves or on the fruits. So we can improve pest control, which can again give improved productivity. So then I also kept some slides on poultry, but I'm not no expert on let's say this, but I try to put few slides on this. So in poultry, the main the important parameters to monitor are the environmental parameters and the ambient parameters in the, let's say, if they're enclosed in some place. The main thing is that we need to monitor humidity and temperature so that they should feel comfortable. The chickens should, or let's say any the birds, they should feel comfortable so that the productivity is improved. And these parameters are very important again during the brooding season, the first to 8 weeks. And then the most important parameters are again CO2 and S3, and high levels of them can cause diseases in the chicken and decrease in productivity levels. Then lighting conditions have to be also maintained properly. Then we have to also monitor what the feed and water, right? Like properly. Then let's say we should not be giving too much or too less. So that is again important, and keeping a proper hygiene, and then cleaning the manure, and then maybe use it for the compost or fertilizer as a fertilizer, organic fertilizers later on. So all these things, and we can also have a camera to monitor the whole place. And we can also, so this is about, this first few points are on monitoring, and then the what kind of actuators we can have, like ventilation, to remove any harmful gases like NH3, CO2. If the levels are rising, we can automatically, here the humans don't need to be in the loop, and like automatically once the levels go beyond certain levels, the exhaust can start, and basically it can also cool. What can happen is that this information can anywhere be sent to the owner, or let's say the facility manager, for their information. And then again, heating, lighting, and curtains. Let's say if it's a daytime, why do you want to use lights? Automatically the curtain should come up based on the time of the day and the weather outside. So again, especially during the brooding time, all these parameters are of extreme importance, and they have a slightly varying schedule, that the water has to be on room temperature. Then the heat lamp starts with 95 degrees Fahrenheit, and then you reduce 5 degrees, and then you start reducing the lamp. Let's say every week you start reducing the temperature as well as the time it is on, and then turn off the heat after a few weeks. So and the benefits is that it will basically improve the productivity, and then the most important thing is that it will reduce any human intervention. So I'm saying that way you can have very few people managing huge, let's say, places, and this will also optimize the feed and water utilization. And the best thing is you can actually monitor from anywhere. So I hope that you might have seen a lot of use cases where in the agriculture, one of the pain points have been that farmers have to go in the night or early morning to switch on those pumps, water pumps. So now that can be done remotely. I can actually monitor and control those pumps remotely. So one very, very convenient. Same thing can also be used in the poultry. So I would like to, let's say, if you have some comments, or if you want to ask questions here, because you might have a better idea what things to monitor and what things to, maybe I can comment, or maybe I can note down. So is basically IoT being used in let's say, can you at least comment on the use of IoT currently in India, or let's say?
Hello.
Yeah, please go ahead.
Yeah, I'm Dr. M. Reddy. Yeah, actually, this type of technology is being used in environmental controlled houses, actually, where they maintain this temperature, humidity, and as you rightly pointed out, that carbon dioxide and carbon monoxide, ammonia level monitoring in the sheds. Actually, these are completely closed houses. There will be some cooling pads. So there will be tunnel ventilation. So they monitor this, inside the houses using this type of technology, what I feel. The sitting from outside, somewhere in the manager city's house, he can monitor what is going on in the these sheds. That much I can say at present.
Okay. So one very interesting thing which can happen is that if we collect this data, right now everything is automated. It doesn't mean that we are saving the data. I don't know if we are saving the data, but if we save the data, that will tell us, and if you run some machine learning algorithms on that, we can get, because see, the relation between the different parameters is generally non-linear. We try to linearize it and give some equations. So in this kind of conditions, if you run, let's say, AI/ML kind of algorithms, you might get very interesting insights on a long-term basis. So that may be of interest. I'm saying automation, I understand, but I don't know if you are collecting any data there. So that may be very interesting. Any other comments or any other like points you want to make? Because you are the expert, I just want to get your views. If you have any question that how IoT can be used here.
Any questions? Any questions from participants?
Okay, fine. Okay, so anyway, we can again ask, like, you can always ask question at the end also. If you don't have any questions right now, I will wait. Then let me then go to the other use cases, and then I will move to the activities at IIIT. So I just want to make a basically, I want to distinguish basically the difference between a consumer IoT and the industrial IoT. So in consumer IoT, all the examples what we have seen till now, they are consumer IoT. I'm saying they are simple and low risk application. Anything happens, we can use low cost sensors, and anything happens, I'm saying production or people's lives are not at stake. Okay, so what at most what will happen, that Amazon Dash, my order will come late if there's a fault in the device, right? Let's say in the next part, slightly temperature will be high or low and my bills will be slightly higher. But I'm saying it's not a very, people's lives or the production are not at stake. But in industrial IoT, let's assume that you have a whole supply chain and then you have the whole manufacturing pipeline, or what's it called? So forgot the name. So basically that the whole pipeline is there one after another, production line, right? So basically you have production line. There any malfunction, right, might stop the whole process, because everything is basically dependent on the previous things. So the previous tasks. So the whole thing might stop, and it can lead to loss, or huge loss in terms of revenue, and also the lives are also at risk, right? You are working with machines which might be lethal. Any error, so that is that is the reason the sensors in this case, since because we are talking about high risk application, so the sensors in this case have to be very precise. So you take an example of aerospace, defense, healthcare, and energy. These are very, very critical areas, and but definitely IoT can help here in improving the productivity, safety, reliability. It's just that it will be slightly costly. Solutions will not be low cost but costly. And then even in the times of COVID, IoT has been of immense help. So I will talk about two particular applications where, or two sectors where this has made a huge difference. One is health, and the second is the manufacturing. So in health, basically we can now remotely monitor COVID suspects and patients, and we can also do video calling for any kind of telemedicine. We can also do compliance regarding, let's say, mask or no mask, people are following social distance or not, using let's say IoT. For manufacturing, like they have suffered a huge amount of losses in the lockdown periods, and since then the focus has been on to get back as compared to make huge amount of profits. But and here the IoT has really helped. IoT has helped basically industries to keep going on. And one of the ways in which it has done is that it has reduced the number of people on the shop floor. So when I say reduce the number of people on shop floor, it means that half of the people will be on the ground in the company, and half of the people might be maybe at the home, and remotely they are trying to monitor and control the processes. So wherever it's possible. So that way it has tried to still make sure that the things continue. So let me then talk about the IoT activities at IIIT. So the first one is the IoT based air pollution monitoring, and all of them are my activities where I'm really like where I'm actively involved. And there are again 4 to 5 other faculty who are also working on IoT, and they're also very active. So there are like huge amount of activities going on at IIIT on IoT. So so the first one is IoT based air pollution monitoring, and we all know that air pollution is a very big issue worldwide. Millions of people are getting killed because of the air pollution related diseases, and many more will become sick. So we need to monitor air pollution. So if you see one of the worst things which are happening with pollution is that we can't see. It's like the road, we can know whether the road has potholes or not, but we don't know the pollution is there or not because we can't see it. So that is the reason it's very important to monitor air pollution. So basically, if you see on here on this map, Hyderabad map having 650 kilometers square of area. So only 6 pollution monitoring stations are there from the Central Pollution Control Board. So what we want to do is that in this small patch of 4 kilometers square, we want to deploy 50 low-cost sensors. So obviously, there is why the government has deployed only 6, because this air pollution monitoring stations are very costly. They are accurate, but they are very costly. They need a lot of maintenance. They are big in size. They need almost one small room to maintain, and you need really expert people to maintain them. So what we are going to do is that we are planning in the small green rectangle. We are which is represented here. We have deployed 50 air pollution nodes already. They are low cost. Obviously, we can't afford 1 crore or 2 crore worth of sensors. So these are very low cost sensors, and we have started deploying them. The point is that if you see here, it is very difficult. The pollution changes every kilometer or 500 meters of kilometer. So let's say the pollution in Bolaram is not same as pollution in Secunderabad or pollution in, let's say, University of Hyderabad or pollution in IIIT. So these 6 monitoring stations are not telling you the pollution in your region, right? In where your houses, where your offices, where your schools go to, where your kids go to school, where you go to malls and public places, right? So it doesn't tell the pollution levels. So what we want to do is that we want to understand what is the street level pollution, right? So that's the reason we want to do a dense deployment of the sensors. And this is like a multidisciplinary project where we want to also understand what is the effect of pollution on health, especially of people like security guards or traffic police who are standing there almost 8 to 10 hours a day in peak pollution. So, so the idea is that we'll collect pollution using IoT network, and we'll collect health data using surveys, and then do some cloud computing data analytics to basically understand what is the impact of pollution on public health. And we will. The idea is also to create a website where we can see this, visualize the air pollution. And then obviously this will go to governance. When I say governance, it includes both citizens as well as the government to take appropriate actions. So this is the first phase of our development of the air pollution node. So initially we started buying something from the market. First issue was they were expensive. Second was there were a lot of bugs. And when we started working, trying to track the values with good quality sensors, we found that some of them don't even work properly. They're just showing some values. Okay, so so we started designing few things inside the house, and then this was the first one which our undergrad students came up with, and we deployed this, and this has been running since last 2 years now. So this we deployed 10 in 2019, almost 3 years now. And second phase, we wanted to go outside IIIT. So we wanted something which is very robust. Otherwise, every other day we have to go and fix the nodes which are not working. So we along with one company, we made a very product quality, low cost pollution node. And you can also see the form factor is very compact. It can be put on the dashboard. And so we already deployed, by the way, this 15 nodes are deployed 3 of them have been deployed in Genius buses. So we will also deploy in future in Easy Commute and Genius buses. And we have done some machine learning based calibration for the PM sensors data. So it's not that we just put the sensors and then started collecting data. We have to also do calibration. So we put our sensors along with the reference grade sensors and then calibrated our sensors with reference to that. So this is the deployment, and you can see actual deployment, which is very rare in academic institutes. I'm saying academic institutes going and deploying things is not very common. And this is a year, like a 2-3 year long project. So you can see that this is a website. You can go here and actually see the air pollution levels in different regions here. Some of them are actually on the road also, this road. And if you click this pointers, then you will get this kind of a 24-hour map with AQI, PM10, PM2.5 temperature humidity. We're still working on gas. Gas is very tricky. And these are the reference sensors, and we are actually calibrating our sensors with this reference device from New Zealand. We are also collecting data across streets. So basically, and you can see that we have collected data. This is from Genius buses. So 2 of the buses I'm showing data, and then we collected manually in the different regions. And one of the students also went from Hyderabad during lockdown to his house via road, and he took the air pollution node and then came back to Bangalore and then came back to Hyderabad. I'm saying, so you can see that we have collected data across like Hyderabad as well as India. So we have done a lot of work in this, like we have published papers, patents. We are also doing indoor air pollution, and our students are winning a lot of hackathons on air pollution. And this is CO2 monitoring. So basically for COVID minimization. So we also deployed 20 of this during the peak COVID to make sure that this will tell us whether people are crowding some space or there's a ventilation is not proper. So based on CO2 levels, you can tell, basically you can estimate that you need proper ventilation after this if the values are high. So a lot of my MS thesis students are working on this, and we have published a lot of journals, filing patents. So we are designing anything with IoT, any hardware comes into picture, we are filing patent. Several challenges. We need to take so many permissions, we need to do so many bugs are there, solutions are costly, and deploying is very challenging part. So one of the locations where we deployed here. So this is a botanical garden in Gachibowli. So there is no power supply in 500 to 600 meters range. So we had to spend 25 rupees just for the power cable. So I'm saying that there are a lot of deployment issues which are not very clear once you start working on this. So, and people have tried to also steal our boxes and adapters from campus as well. I'm saying, so those kind of things keep happening. So second thing is IoT based water flow monitoring. So IIIT has around 20-25 meters in the campus for water distribution across. So what happens is every day plumber will go twice a day to note down the reading. So what they do is they will take pictures, go to the office, note down the values, feed it to computer. So we wanted to digitize this automatically, like everything should happen automatically. So what we started, we bought some solutions from the market, but they were costly. So like for 2 to 4 inch pipe, the cost of the digital water meters is almost around 40 to 50,000 rupees, and the budget we had was very less from the project, from the funded project. So what we said, we bought some, but then after we started developing our own solution. So what we did is see, when you replace an existing analog water meter with a digital water meter, you're throwing away a perfectly fine working analog water meter, right? So what we did is, we, instead of throwing it away, we just put a camera on top of it and run some machine learning algorithm to convert the picture or image of that dial, right, to numbers, and send that number to the cloud. And the whole solution costed 5,000 rupees. And our students, second year students have done this, and they have filed patent, they have published conference papers, they also won the water challenge by Telangana state government. Pretty interesting solution. So this we have, the rest of the solutions we have deployed is this one in the campus. We are also planning to start a company based on this. This is again dashboard, but still the dashboard is not in a proper shape right now. We are still working on it, but we are deployed. You can see that 10 off the shelf and 15 smart water meters we are deployed in the campus. The third activity is a remote triggered lab. So the basic idea here is that I can see we have experiments, right? So physical, there might be, let's say, school level or college level experiments, setups which we are not able to access during COVID times. And let's say some of the colleges or schools, especially in rural areas, might not even have access to this because of the costs. So what we are doing is we have attached sensors and actuators to this physical setup and attached a microcontroller, and which is basically connected to the internet. And through a dashboard, anybody in the world having a browser can access this physical setups. Okay, and then do a experiment. Okay, so let me quickly show you a demo. I hope the time wise, I don't know how we are doing.
No problem.
Okay, so let me quickly see if it's running. Sometimes it keeps okay, it's waiting room. Why is it waiting room? I just tested it. Okay, so okay, thank God it's working. Okay, so this is a focal length experiment. So our students are trying to fix things at the ER. Okay, so if you see, I keep this and then so you can see there's a screen on the left hand side, and on the you can see that this is moving now. And this object will also move. So there's some delay. I hope you are able to see my screen. Yeah.
Yeah.
So you can see, and you can see the image here. It's not easily visible, but yeah, but you can see that it's not very sharp, and I can basically make it the lens. Yeah. So you can now see that the image will become slightly sharp. There's a delay. Okay, so we are still fixing it. Our second year students have done all the whole thing. You can see the delay. Now we can see that suddenly it has become sharp, right? The image. I hope you are able to see this. Are you able to see this? So the focal length of this particular lens is actually 10 centimeters, and you can see that the image is sharp, and if I change maybe something like this, it will go away. You will not be able to see that. Again, there's some delay. Yeah, so this the focus has gone now. You can see that you're not able to see anything here, right? So this is one of the, so let me tell you what was this. Session. So basically what we were trying to do is a school level experiment where we want to understand what is the focal length of this lens, convex lens. So object I showed was a color that F written, right? And so based on the object distance from the lens and the image distance, right? I can find what is the focal length using this expression. So that's what we were trying to do. Now I can do this experiment remotely. Anybody in the world can do it. I'm saying you guys can also do it. Try out. So we are building a lot of experiments for this. So another thing, two things are working, others are not. So I'm saying we are still building this. So this is vanishing rod experiment. What happens here is that there's oil and there's a water, and then there's this glass rod. So this glass rod has basically same, okay, it has the same refractive index as the oil, so it is not visible here. On the other hand, it's visible here. The refractive index is slightly different for water. So you can see that now I can pull this also up. Okay. I think those guys are working there. Maybe they are working on this, trying to fix it. But I think you get the idea, right? I'm saying that okay. So we are building this kind of things so that then ultimately what the idea would be that we want to. By the way, the whole setup our students have made, second year students have made it, and the idea is that we will work with the NGO to scale this and so that we can provide this to let's say schools and colleges. The final activity I want to show is the Smart City Living Lab. So we had established the Center of Excellence on IoT for Smart Cities in 2019, and which resulted, like the activities there resulted in this Living Lab project and the Smart City Research Center at IIIT. So, so we have built this India's first Living Lab for Smart Cities, which is funded by MIT and Smart City Mission. And the idea is to have different verticals or IoT applications in the campus. See, campus is a pretty decent size, 66 acres, 2,000 to 4,000 population, floating population, people coming in, people going out, and some people residing in the campus. It's like a small city, having all the things which may be needed in a city, right? So basically, this is a very good place where you can do experiments. So that's what we are trying to do. We are trying to deploy IoT related applications. And we are calling this Living Lab, which is a different from, let's say, general research institutes, is that even third-party applications or third-party companies or startups can actually come and deploy the solutions in the campus. That's the differentiator from the usual research activities. This is the Living Lab team, and Ramesh is the PI, Ramesh Loganathan, and then there's a few professors. Almost this 5 professors are working. Anuradha is the lead architect, and then we have a lot of students also working, and also visiting faculty from different colleges. And the objectives of this Living Lab is this: that we want to do research on different IoT verticals for smart cities, and then we want to collect a lot of data for AML. IIIT is very well known for AML research. But here we are generating a lot of data which is relevant to India. A lot of times people just pick up data from Western countries and try to apply, but Indian conditions are very different. So that's what we are trying to do. We are trying to create data sets for Indian context. So by the way, each of our pollution node is collecting almost 2 million data points per year, and I have 50. So like 100 million data points I will have at the end of 1 year, which is a pretty big number. And then, as I mentioned, this will also serve as a test bed for smart city deployments. And definitely we want to promote startups in the smart city space. And these are the themes currently we are working on. I will talk about water monitoring, and other faculty are working on safety and security. I'm also working on air pollution. Some people are working on social distancing, energy. Yeah, so with this, I think I'm on time. I end my presentation. I would be happy to answer your questions, and I really thank you for this opportunity. Please ask if you have any questions. Am I audible?
Any questions? Questions from participants?
Sir, I have a question, sir.
Yeah, please go ahead.
Not directly related to this. Whether you work on developing apps
So we have developed an app for air pollution monitoring, the project we are working on. It's available on Android, not on iOS, but I have been kind of guiding also other colleges. So I think sir might know that I'm very actively involved with GNIT's Gene Adama Institute of Technology and Science. So one of the student teams there have created a GPS based solution. Nothing new as per, but I'm saying they have created a solution which will be used by their own college for bus tracking. So students can know, or students and faculty can know where the bus are. So there they have also created an app.
In this our institute context, I'm interested. I'm working in semen biology, and semen analysis is there. We collect and then bring to the lab and then see the concentration or motility, sperm motility, through camera and then system-based software.
Okay.
So for just monitoring in the shed itself, just to take a small portion of the semen, dilute it, and then there itself we want to see the concentration and gross motility. So for this, can any app can be developed, sir, and run by this app?
So app can be developed. I think app is not an issue. The question is the software. Like, does it need any special scientific let's say process?
Standardization will be required.
Any what?
Standardization of those dilution rate, those things.
Yeah, that can be, I think, easily done in the sense you can actually carry a kit and do everything there itself, right? And like you can also use a mobile camera, which can, yeah, app can be made. I don't see that's the issue.
Is there any possibility of collaboration with them?
Sure, I'm saying we are always open. The only question is will be bandwidth, how much time faculty may have. But I think that's not like we can think about it, discuss how the solution is like how. I think this is must be possible. I don't see that as an issue.
Contact with them.
Sure.
Sir, our institute may have collaboration with your institute for research activities.
Sure.
In the field of Internet of Things related to poultry, especially what Shanmugam has pointed out regarding semen biology techniques for the artificial insemination and all.
We can also, if you would be interested, actually, like we can also have simple things. We can start with simple things like temperature and humidity control. Yeah. I don't know if you already have that, like throughout the space, the poultry farms. I'm not talking about one sensor, and I'm talking about multiple sensors in that to map the whole 3D model of the temperature humidity in that space.
Yeah, it is not there. I think that is a good idea. Only manually we are recording in some sheds actually.
I'm saying that can be easily automated. There's nothing. I'm saying I can take some students who can do this project, deploy. That should be easily possible. You have Wi-Fi, right? Even if you don't have Wi-Fi, we can still do. I'm saying those things are very easy. We can give this as a project to students. I'm saying they will do it. In 2 months, they will do it. I mean, if you give me people, they will do it. I think the main issue is not technology. Technology is very easy to use. It's just the adoption. Like the threshold for adoption here is less as compared to the technology is very easy.
Okay. Any questions from the participants?
If you want, I can give basically a proposal along with some college, maybe unit itself. I can write a proposal and we can get that at least the basics thing started, and then we can keep increasing the complexity or IoT applications.
Yeah. That is a good idea.
Yeah. So what we are doing is, see, we can't do everything. We understood that, right? We are already doing too many things. So what we are doing is we are guiding actually 6 colleges. So even in GNITS, like Shrikant sir is working with me. So and few faculty will be working. So we can start working with them, and then basically students will do this. I don't see any issue.
Okay, in future we'll cooperate,
By the way,
collaborate.
open house system, that's not difficult. Environmental monitoring. So if you are, see, temperature humidity, there's no issue at all. Issue might be in, let's say, gas sensors. See, gas monitoring is very tricky. The kind of, first of all, nobody wants to put any money on the sensors. Sensors are very costly. We are not developing sensors in India, and we don't want to put any. So whatever sensors you are getting on off the shelf are like at low cost are not working. People are selling anything. I'm saying they don't work. If you try to check it with reference, it will not work. They will sell you for, let's say, lakhs and lakhs rupees, but they will not work. So you need to be very careful when you're buying anything on gas. Temperature, humidity, no issues. Particulate matter, no issues. It will work. Gas, very tricky. But we have, but don't forget that we have deployed 50 nodes outside in open street under the sun, 24/7, and they are working since last 1 year. So we can easily deploy those kind of sensors. That's not the issue. I don't have any idea on startups working on poultry.
In industry, it is upcoming now.
Yeah. I'm saying, see, IoT, this is the time for IoT. Next 5 years, we'll have everything IoTized. Every application, see, the only thing is you have to connect the internet to the thing. That's what. People have started applying in different areas. Maybe your institute can take a lead on this and start applying IoT in different. I already Shanmugasan, I think he had a good idea. Something that will need some, let's say, proof of concept. But I'm saying the temperature humidity monitoring is the easiest thing to do. I'm saying college kids will do it. Okay, sir. So I think yeah, I'll stop here.
Very good presentation, Sachin. Thank you very much.
For the opportunity.
Thank you very much.
Thank you.
Any questions from audience?